Welcome to Sravz Technical Series. This is session 4 of the LangChain Python-based implementation discussion we were having. So in today's session, we'll continue discussion of the supervisor agent model. I updated the code a little bit to make the session 3, we did the demo and we saw that there were loops that were happening between the supervisor and the agent. We have a supervisor, then we have a JSON agent and the Pandas agent. The idea was to let the supervisor call the JSON agent, get the data, it routes back to supervisor, and the supervisor should call the Pandas agent. Pandas agent will create an HTML output, and then the supervisor will stop the process. But what I saw is in session 3, when the supervisor calls the JSON agent, there is a continuous loop, and this loop is causing the LangChain process to go forever and it doesn't exit. So in today's session, I made some more changes to the code base. I'll discuss that. I'll switch to the Visual Studio Code discussion. I'll start the agent. Once again, I'll run it. So while it runs in the background, we can discuss further. I started the agent supervisor. It is running. So while it takes a while to finish, I'll go through the previous run. I started before I began this video, I executed the agent supervisor. So it ran, and then the agent supervisor pulled the input data from S3. I'll discuss that in a bit. Instead of hard coding the input files, we pull from S3 now, like this. We pull from S3. Then after we get the 5 mutual funds from S3, I stitched those 5 mutual funds into a single JSON output with top holdings as the key. So that way we get the relevant documents. And then once we have the relevant documents, we post this to OpenAI. And then the OpenAI will use the JSON agent to get the top holdings key, like it did here, the list of key, top holdings. Once it gets the top holdings, the JSON agent will send a message back to the supervisor. The supervisor will call the Python REPL agent, and the Python REPL agent will pick the JSON for that particular key, and then using Pandas, it will create a HTML file like it did here. So I'll open the HTML file. This is the HTML file we are generating, and the HTML file is not the complete file. Sometimes it says it only prints a partial HTML file, and then it says this code will loop through each, and then it doesn't print the whole HTML file. Each run produces a different output. Now this is the second run, the one which I just started. So it got the JSON file, then it got the relevant document, then JSON agent pull the top holdings key. Now Python REPL agent is running. So I'll let it run. I'll switch back to the documentation page. Today I'll show what is LangSmith and why we need LangSmith. If you see the output here, we are going to the console, and the console was displaying what the LangChain process is doing. We have it in the debug mode. So we get these messages from LangChain. But this console output is difficult to follow through because it is it's all not well formatted, and also the output is generated here. We'll see the output now. So it generated the HTML file, which is good. We'll go through this HTML file in a bit. You see the supervisor calls the agent calls back the supervisor, then the supervisor calls the next one in the chain. So following the flow through the logs is difficult. So that's why we can use LangSmith to see the LangChain graph. So to enable LangSmith, we have to just export some variables like this. LangSmith endpoint, LangSmith tracing API, v2 is true. If you set it to true, LangSmith will receive the logs from our Python code, and then LangChain project, etc. And then this key you get from LangSmith. I'll switch to LangSmith UI. It's a hosted version of LangSmith. Here, once you go to LangSmith, you create an API key and take that API key and export it here. And once you have the API key set and these variables set, then whenever you run the agent, it will create a LangGraph like this. So for example, I just executed this one at 11:55. It's 11:59 now. It's 11:59. I executed it at 11:55. So if you expand that, let's just expand this run. Now you see the flow easier in this graph. So we started the application. Supervisor was executed. Supervisor executed JSON agent next. The JSON agent passed back the control to supervisor. The supervisor called the Python REPL agent, and the Python REPL agent created the HTML file for us. And then the supervisor completed the flow. So this way in LangSmith, you can see the flow that is being followed by the LangChain graph. And we'll just open the chat OpenAI screen. Here it shows us what OpenAI did, what inputs OpenAI received, and what were the outputs. So when the supervisor is an agent, in fact, it's an agent. It has a route function in it. The supervisor agent, which has a route function, will give this input to OpenAI, and we ask, given this input, and this is our human message, OpenAI will process it, and then it will give us an output. What should be the next agent which will act on our input data? So then once we get the JSON agent, the supervisor will start the JSON agent. Now the JSON agent will do the same. We'll go to chat OpenAI. The JSON agent has these tools. Given these tools, now JSON agent will again use OpenAI. Given these tools, and this is our message, we ask the OpenAI what to do next, and OpenAI tells us to pick the top holdings key from the provided data. So that's what we did. We get the top holdings key. Then we again asked chat GPT, provided these tools, what should I do next? So we got this top holdings, and then the process will continue. We won't go through the whole graph. Eventually, OpenAI will pull out the JSON data from top holdings key. So that's how we get that tool. Get value, we got the top holdings key, and then we got the list of top holdings key. Now OpenAI said it will generate a Python code to list all this in an HTML format, and then OpenAI wrote the Python code for us. So this all happened in the JSON agent. Now the JSON agent completed, then we go back to the supervisor. Now supervisor will ask the chat GPT again, given all this data, right? Given all this data, we have Python code to what to do next. Then ChatGPT will tell the supervisor to run the Python REPL agent. So now the supervisor calls the Python REPL agent. So since we have Python code and we also provided an agent which can run the Python code, ChatGPT tells supervisor to run Python code using Python REPL agent. And then, so that's what it said. Next is run Python REPL agent. So we ran the Python REPL agent. The Python code is successfully executed and this output file is generated. So that was our prompt. We said, given this JSON file, get the top holdings, generate an HTML file of those top holdings, and save that to temp directory. That was our prompt. And then Python REPL agent did that. And then we passed the control back to the supervisor. The supervisor will say, I did this. Now the ChatGPT will tell supervisor, output is finished. Since the ChatGPT said to supervisor to finish, the supervisor will finish the flow. So that's how the LangGraph works with multiple agents. So with this LangSmith, you can see the steps taken by the LangGraph, and if there are loops, sometimes after the supervisor, the JSON agent runs in a loop. You have to update the JSON agent, or you have to update your prompt such that there's no loop. So that was the change that is about LangGraph, why we need LangGraph. Now I'll mention a little bit more about the relevant documents, why we need to make the relevant documents more relevant. I'll discuss the changes made to the relevant documents portion of the code, LangChain helper. We do get all documents from ChromaDB. Now, when you get the documents from ChromaDB, this code base is in the gist. This code base is in the gist. So you could, here I'm only showing the differences between the previous and this version. So you can go through the code base in the gist for better understanding. So in the relevant get documents from ChromaDB, instead of getting the documents from the local file system, now I wrote this function which will get the JSON from S3, and then we pass that JSON data to JSON loader extender, and then the loader will get all the documents in that JSON file. So we did that, and then we get all the documents from the JSON file. Then we load those into this dictionary, and then we add a code which is equal to the file name to each document we generate from the JSON files. So I mentioned this in the previous sessions. We have a huge JSON file. We split it into multiple chunks. Then each chunk should still contain the document file, the file name, or else the chunk will become irrelevant because we have broken a single file into multiple pieces. Now, if we don't put the file name in the individual piece, then those pieces will become unrelated. So we want to still make them relevant, related. So we added a file name to each piece that originated from that JSON document. Now, once we get the relevant documents, I made another code change here. where we go through so we had a document, we have broken it down into individual pieces. Now within that each piece, earlier we just put a file name at a high level, but now instead of putting that file name as code equal to file name as a key in that JSON blob, we go through that each piece recursively, and each and every object we put the file name. So that way we want to make the document more relevant. If we don't do this, then once we send these relevant documents to ChatGPT would find it difficult to relate which document belongs to what. So each and every object should contain the file name. So that way the document is more relevant. So that's what I meant by saying that make the documents more relevant. Recursively go through each and every JSON object and put the file name in that object. So that way each and every JSON object has become relevant. So, and then I integrated AWS S3 with JSONSplitter. I uploaded this code to gist, so I won't go through that functionality. This is just straightforward boto3 call to AWS S3, and then we get the document and then we pass it to JSONSplitter. Recursive JSON, in the JSON toolkit, if you recall, I had some methods. I added some tools, but I removed those tools because when I added more tools to the JSON agent, the JSON agent was looping within itself. So to avoid those loops, I removed the extra tools because these extra tools were confusing ChatGPT, and it was calling these functions, though it need not call this function. So I removed these tools and I just used whatever tool LangChain has provided. LangChain provides us only two tools, get key value, and I think the other one is, if we go to JSON agent, yeah, this JSON agent will expand this. Go to chat OpenAI. So yeah, the JSON agent has only these tools, two tools provided by LangChain. So I just used those tools. I didn't put any extra tools. Only those two tools are sent. So to avoid loops in our LangGraph, we have to only send those tools which are needed for our task. So this is another enhancement you can make. If you find there are loops in the LangGraph, remove the tools which you don't need for that specific task. And then we go to the next item, remove Pandas agent and use Python REPL agent. So you could check the code for that. Initially, I had the Pandas agent to create the HTML output of the JSON data. I removed that and I now use Python REPL agent. So which is somewhere here, Python REPL agent. Yeah, create Python REPL agent, create agent. Before this, it was Pandas agent. Now the LangChain Pandas agent internally uses Python REPL agent. So the way Pandas agent works is it creates an data frame, sets it up in Pandas Python REPL agent, and then forwards that Python REPL agent to LangChain. So that way that data frame is hard-coded. But we need a dynamic data frame. Based on the mutual funds code we use, we need to create that data frame dynamically and send it to the Python REPL agent. So for that reason, I couldn't use the Pandas agent. Instead of that, I just provide the whole Python REPL agent to LangChain. So that's why I removed Pandas agent and used Python REPL agent. And now for the sample queries, I showed the sample queries. I'll go back to the window, agent supervisor. So we go all the way to the bottom. So after multiple iterations, I updated the code base a little bit more. So you can go through that in the gist or ask in the YouTube channel. So this is where our prompt is. Use JSON agent for given JSON, get the list of top holdings key in top holdings list. Write Python code that will loop through the entire top holding list for every code. I had to specifically mention loop through the entire top holdings list, because if I don't say this, then sometimes when ChatGPT receives the top holdings, it just uses top 3 or 4 items in the list, and then it says, puts a comment saying loop through the rest, and it doesn't loop it. So I put this loop through the entire top holding list so that it explicitly goes through the entire list and adds them to the Python data frame, and then every code and write the HTML. So that's how the prompt is set up. And when the prompt runs, this run seemed to be a better run because it generated the whole HTML file. I'll open the HTML file in HTML formatter. So if you look here, we have around 49. It starts from 0, so it makes sense. So it generated the HTML for the top 10 holdings for each mutual fund. And if you look at NVIDIA as the top holdings are about 11% for FPGRX, which makes sense. So we gave 5 mutual funds and it was able to get the top holdings for all those from our JSON file. So at this point, I'll close my LangChain part of the sessions. If you have any questions or comments, you can reach me out in the YouTube channel or in the documentation page. And the next step would be to integrate this into our REST API framework, and then we'll plug this in the UI so that in the UI, when we query, we get the data as an output in the UI itself. So if you have any questions or comments, please reach me out. Until next